Okay, we are a little bit early, but I think I can use some spare time. So, hello, my name is Jānis Meģis. I am a technical support guy for MikroTik for almost 13 years now. And my guys asked me to make a presentation, but when I chose the topic, it looks like all good topics were already distributed between trainers, so I said, do what you want. So, for example, no, do a presentation about features that clients don't know how to use. And instantly I got the idea, Masquerade. And that's it. So there will be some more things, but yeah. So the official name of the presentation is Most Underused and Overused RouterOS Features. Unofficially, it's my first attempt on Holy War against the Masquerade. So, presentation will have simple objectives. So, first, to help you understand and diagnose most common RouterOS configuration issues, how to properly use some RouterOS features and avoid configuration problems, encourage you to use latest RouterOS and latest features in those systems. And of course, the most important thing is to reduce the number of emails to support@mikrotik.com. So basically, how do you diagnose a problem in MikroTik RouterOS? It's very simple. You use tools, and if we're talking about tools, all of them are in this window. So here you have interface. You can see traffic over there. You can use torch. You can see tools profile, distribution of the CPU load with topics. You can also see this, how your CPU load is distributed through the cores. So all the tools for you to find out what your problem is actually there. And unfortunately, half of the time, MikroTik support just asks you the question, can you please run tool profile? Can you please tell us what's there? What do you see on interface? What does your sniffer shows? We ask these questions, and then the problem and this ticket suddenly dies. And only two weeks later, oh yeah, guys, thank you, we found the problem. So, presentation plan will consist of most popular common configuration issues sent to support@mikrotik.com. I collected this data over a few months. That's on my topics. Of course, there's wireless issues and so on. Those tickets that come to me on firewalling stuff, CCR performance stuff, and such things. Basically traffic flow and so on. And I try to make compressed, combined, simplified examples for the purpose of this presentation. So each example will show what was the problem and how to correct one. So problematic configuration and correct configuration. Don't confuse them. So let's start with the first and most annoying, high layer 7 load or high load in general. So typical configuration looks like this. We have layer 7, 2 regex for YouTube and Facebook. Then we have a firewall rule, which is quite simple. Just action drop, chain forward, and layer 7. And 3-4 such rules, and you can kill your CPU performance of any router, even CCR. Why is that? So, problem is high CPU load, increased latency, packet loss, jitter. YouTube and Facebook is not blocked, actually. So you get the load, but no the effect. So how to diagnose this problem? Of course, we ask you to open up tool profile, and of course you will see a high layer 7 load there. And what is the reason for this? There's only two simple rules. Well, each connection is rechecked over and over and over again each time your firewall drop rule is triggered. So every time the packet comes in, it needs to be checked against that layer 7, all traffic, not just any traffic, but all the traffic that goes through your forward need to be checked against that layer 7 regex that you send. So basically layer 7 is checked at the wrong place and against all of the traffic. So to understand the problem, let's go into the layer 7, how it works. So first of all, it works for ICMP, TCP, and UDP streams. When you give it a regex, it will take 10 packets, or first 2 kilobytes of the connection. It will collect it, so it's not just one packet. So to collect actually 2 kilobytes, you need at least several packets from both directions if TCP. So it collects those packets, it stores it in memory, and then it checks. So every time you trigger that rule, it needs to collect next few packets, check, and then they only decide to drop. So imagine this happening over and over and over and over again for each and every connection. And if you saying that maybe my layer 7 pattern checks something deeper in the connection, well, no. It's more or less a standard. All the patterns that you can find on the internet, they are for these first 2 kilobytes or first 10 packets. So you may ask, what is the correct implementation? So first of all, if you just do a simple log into that drop rule that you did in the previous mail, you will see that the only packets that matches those requests are DNS packets. So that filter, those 2 filters that we added, layer 7, is only for DNS requests. So you're not blocking Facebook traffic, you're blocking Facebook requests to the Facebook. So what's the point checking that against all the traffic? You can check that only against the DNS requests. So protocol UDP, destination port 53, and this is very important, I check only unmarked connections, those connections that we haven't checked yet, that doesn't have any marks, and I add special connection mark that it's a YouTube connection. Then I mark all the packets with the YouTube packet from these YouTube connections. And in filter, I drop all the traffic with the packet mark YouTube packet. And I drop it also in forward and in input, because maybe you have a DNS cache, and that was the reason why the Facebook was not dropped in previous, because you did it only in forward. So by checking how you use layer 7, basically this takes no CPU power at all, and it actually works. So all the requests from your computer browsers are working fine with these regex. Unfortunately, phone apps is a different story. You need different regex for those. But with just simple adjustment, you can solve your layer 7 load. So please check, guys, that you use your layer 7 regex properly, because this is a very common issue. Okay, next most popular email to support, my queues doesn't work. Maybe somebody can guess why. So I combined several problems at this one. So we have 2 local networks, let's say computers and servers, for example. And we use one of the new RouterOS versions, which come with the fast track connection pre-installed, pre-configured in default configuration. And then person adds simple queues. In here, there's 3 big problems. So this is wrong. What is these problems? Very interesting description. My queues start to work only when I enable tool torch. strange, no? No, it's not strange because when you enable tool torch, your fast track stops working because torch need to capture traffic. So the packets go slow pass way instead of fast pass, so it get to the queues. Why does my packets go fast pass if I have firewall and so on? In previous slide, you were able to see there was fast track connection rule, which allows packets to use connection tracking and still go in fast pass. So you cannot have queues and fast track connection for all traffic at the same time. And that giveaway, how to diagnose these, look at the counters of the queues, look at the counters of fast track connection rule, and it will be clear that nothing gets through it. So the reason, there was two problems that, first of all, fast track traffic was for all traffic, and simple queues target was not specified. So just to remind you what the fast track is. So fast track connection rule allows you to add a flag in connection tracking, and that flag marks this connection for fast processing. That means that you allow this connection to bypass everything else except connection tracking. So it works only for TCP and UDP. And these packets, as I already told, will skip queues, will skip firewall and other things on the path in packet flow diagram. So, but no, again, some packets we need to pass the regular slow pathway so to maintain those connection tracking entries. And the next thing is very, very popular in simple queues target. Target is an only option that determines simple queue direction. With specifying target, you said what is upload and what is download. If your target is not specified, it's 000/0, that means that this queue will capture all traffic. And what is interesting, all traffic will be considered download, because download is captured first, because everything is download for 000/0. So destination option that everyone uses is just a simple additional filter. So that filters some traffic out after the target. So it doesn't determine direction. So correct implementation in this case. First thing, you don't have to use fast track connection for all traffic. You can specify something. For example, you don't want any slowdowns from your local network to another, so that your computers get to your servers the fast pass way. Then you can specify the traffic from one local interface to another, or from the second to the first, have this fast track connection, but the rest of the traffic goes the slow way. And of course, instead of destination, you need to use targets in your simple queues. One target, which is 000/0, can break all your queue setup because it will capture all the traffic and nothing will get to your next queues. So, example number 3, high CPU load on my PPPoE server. So what is the situation? Usually we have around 3,000 PPPoE clients, /20 network, connected via separate network to another PPPoE server, which also has /20 PPPoE network, another 3,000 clients. And all the PPPoE servers are exactly in the same backbone area, and redistributed connected routes are enabled. And all the OSPF configuration that you have, you just added these networks to the backbone. Sounds easy, like I do that every day, no? But it's wrong. So what is wrong there? First of all, problem. My CPU is overloaded, my PPPoE clients disconnect, PPP client cannot reach the target speeds, Sometimes I cannot connect to my device. So when you go to and actually find the place to connect to those devices, you see that routing process is holding one CPU at 100% all the time. Sometimes all cores go to 100% with PPP load or networking load. So what is the reason? The reason is very simple. As soon as you open up the sniffer, you will see that OSPF is just spammed with PPPoE /32 routes. So every time some client disconnects or reconnects to your PPPoE server, your routing table changes because /32 route just appears or disappears. And every time OSPF, because it's configured in one big backbone area, just have to make an update. Before it managed to finish that update, you already have another client disconnected and reconnected. So you have an update storm going on over and over and over again. So how to solve this? I already explained this slide, sorry. So how to solve this? Very simple. There's such thing called stub areas, and also there's such OSPF features in interfaces where you can enable passive mode. So not only your area configuration was wrong, but also usually you forget that you need to disable your OSPF to the client-facing interfaces, especially when they are dynamic, because when you configure them at the first place, there was no interfaces. And now 3,000 clients connect, and on each client-facing interface, OSPF is running on and waiting some commands. So additional load, unnecessary load. A stub area allows you to aggregate, so reduce the flooded information into area, and basically, when you are in stub area, all the other area routes are available through the default route. But also, when you use area ranges, feature that we have in OSPF, you can aggregate all /32 routes into 1/20, which is always available. And there will be no OSPF updates floating around your network. So what is the correct configuration? First of all, you create the stub area. You add PPPoE network to that stub area. You enable area ranges with one simple line. And when you specify the OSPF interfaces, you can add in the end one more line, which said that all interfaces will be passive. So all dynamic interfaces that will be created afterwards, all the PPPoE clients will be dynamic automatically. So with just 4-line adjustment, you fixed all your problems in your PPPoE network, PPPoE OSPF network. Okay, next most popular, quite similar to the previous one. I have a high CPU load on my PPPoE server. You already noticed what topics I usually get to the support. So again, similar situation, but configuration this time is much more easier. 3,000 PPPoE clients, /20 network, static public IP address, Masquerade rule, and no firewall. Sounds very simple, but it's wrong. So what can be wrong here? Let's take a look at the problem. So CPU is overloaded. PPPoE clients disconnect, can't reach target speeds. Sometimes you cannot connect to the board. So it's quite similar to the OSPF problem. But this time when you take a look at your tools profile, you see that firewall process. But I have no firewall. I have just one Masquerade. How can I have 100% load of firewall? It's because it's improper use of Masquerade. So, Masquerade is unique subversion of source NAT. First of all, if you have a static IP address, you can use a source NAT instead of Masquerade. Masquerade is only for dynamic addresses where public address can dynamically change. So it's specially designed for situations when those IP addresses changes. So the IP is dynamic or through the tunnel or something like that. So what is this speciality? Why it works better than SourceNet? Every time an interface disconnects or IP addresses changes on the router have to search all connection tracking and purge out all connections related to that interface to improve the recovery time in normal usage when you have one public interface up, down, and then you go again. Now imagine you have 3,000 PPPoE clients that going down and up all the time. Every time one of the interfaces goes down or up, Masquerade has to do his job. It has to clear out all the connection tracking related entries. So it has to go through the connection tracking and search. And this is where your firewall load comes in. So correct implementation is very simple. You have static IP address, use SourceNet instead of Masquerade. Because right now, there's a trend, why use SourceNet if we can Masquerade? And Masquerade everything in every direction and so on. And you guys don't realize that it's actually quite a big problem. So let's go to the next thing. My provider says that my local IPs are leaking to the public network. I have multi-gateway device, so you have load balancing. We have, again, static IP addresses on public interfaces. Again, we use Masquerade. But we don't have PPPoE, so the previous problem doesn't apply, no? Well, there's you wrong. So when failover happens, packets from private IP with the private IPs get out through the public interface. You can actually diagnose that with tool sniffer. And the reason, again, is improper use of Masquerade and insufficient amount of safeguards. So I already explained you that Masquerade on disconnect purges the connection tracking of related connections. So the next packet of these purged connections will come into the firewall with connection state new. And the packets will be routed out via backup gateway. So they will go through the NAT again normally, and they will be NATed through the other gateway. But as soon as your primary gateway comes back, routing will restore over your primary, and packets that belong already to existing connection will be sent out through the other interface without being masqueraded, because they already belong to connection that's already masqueraded to another interface. So NAT has already worked on them, and these packets will just flood out the first primary gateway. So that's how Masquerade works. The problem is that those Masquerade entries were purged at the first place. So if you use SourceNet instead of Masquerade, there will be no such thing as purging out the connection. And if your main link just flapped, your connections will restore, the NAT states will remain, and everything will be fine. If you can't use SourceNet, there's possibility that you have to use Masquerade because those IP addresses are dynamic. You can add some safeguards. First safeguard is to drop connection state invalid packets. Second, drop all connection state new packets that are not destination NATed. And third one is to create a backup black hole route for each routing mark. So when things like this happen, all the packets go to the black hole route and will be discarded anyway. So these are three things how to solve this issue over here. Okay, next one, VRRP and routing problems. I will give you a while to take a look at this. So we have IP address, we have VRRP interface, and we have IP address on VRRP interface. But this configuration is wrong. So any idea what's wrong here? Okay. So problem description. Routing doesn't work properly. My fast track or fastpath doesn't work. Networking process is quite high. As soon as you open your routing table, IP routes, and look at the interface statistics, you will notice that you have two interfaces with identical IP networks on them. VRRP interface and the physical interface, because, sorry, you forgot that on VRRP, you can only use /32 on virtual interfaces. This is the most common problem. If you check all the examples on the internet, they specifically implies that you need to have /32 on the virtual VRP interface. Because first of all, you will have a routing conflict, as there's two interfaces connected to the same network. Second of all, VRP interface doesn't support any acceleration, so it doesn't have fastpath support, doesn't have fast track support, and it's actually quite slow. It increases the load if you try to send some traffic through it. So simple adjustment, if you use VRRP, please check that you use /32. Next, most common problem, DNS cache. So you enable DNS cache, you have a Masquerade, you have a fast track connection, and that's it. You don't have any firewall, only fast track connection. And you have public IP on your interface, on your public interface. So what's my problem? I have high CPU load. I have high amount of unknown traffic on public interface. Well, nothing is unknown at MikroTik. Just open up Tools Torch and take a look, and open up Tools Profile and take a look, and you will see there's DNS packets and DNS load. So if you don't have any firewall on your public network, your router probably is used as open DNS resolver. So it answers recursive queries for hosts outside your network and is used as a DNS amplification attack tool. So, and it's very simple. You just need to add two rules. I prefer to do rejects instead of drops, because on my observation, that somehow make them stop trying much more faster than simple drops. And of course, you need the rest of the firewall. Yeah, these two rules will not fix all your issues. This will just this specific one. So simple, but very, very common. Next one, IPsec tunnel doesn't work. Sometimes the reason are on our side, but mostly not. So typical setup, you have two offices, you create an IPsec tunnel, it connects, it looks like everything is fine, you have Masquerade on both offices, but it doesn't work. So packets are rejected, tunnel can't be established. So if you take a look at the sniffer, you will surely find out that your NAT rule, your Masquerade, is changing source address of traffic that's about to be encrypted. And so that source address doesn't correspond to IPsec policy on the opposite end, so it's discarded. So, and here is one new option that comes in that underused, is heavily underused, is our new raw table. So this table allows you selectively bypass or drop packets before they actually come to the connection tracking. As you know, connection tracking is the most loaded, most heavily loading feature and central nerve system of the RouterOS packet flow. So you can stop some traffic getting to it, which is very, very effective. First of all, you will not have to defragment some packets, because on connection tracking, always defragment them. So you can process them as a fragments if you bypass connection tracking. Also, you can skip NAT configuration, which is very useful in this configuration, because NAT was the problem for IPsec. And you need to just remember that some matchers that are based on connection tracking, they will not work with traffic that have this no track flag set. And you can distinguish this traffic from any other traffic with the connection state untracked. So the fifth connection state appeared in connections in firewall. It's untracked. It's for all the traffic that bypasses row table. So correct implementation is very simple. You add these two rules for your IPsec policy traffic. Add to row. This traffic will never get to the NAT. It will never be masqueraded, and you will be able to process it even faster, because it also skips connection tracking and so on. We are in heavy debates about maybe we should add it automatically, but it can break some of the configurations. So right now you still need to do it yourself. And next thing, setup. I want to securely bridge my two networks, two offices. So what I do, I created PPTP or L2TP tunnel, and I run Ethernet over IP tunnel inside it. So what is the problem? Web pages, very slow download speeds, and very strange suspicion that our competition knows what your secrets. So you can check that by tool bandwidth test. You can check that by tool ping and try different packets without fragmenting. And the reason is very simple. PPTP and L2TP is not considered safe anymore. So if somebody really wants, they can get into it. So, and of course, double tunneling adds a lot of tunnel overhead. So there's fragmentation. And most probably web pages doesn't open because you didn't reduce MSS size to the necessary value, so you have issues with MTU. And correct implementation is even easier. Forget about PPTP and L2TP, just use pure Ethernet over IP, and there's an option IPsec secret, which will run IPsec over your Ethernet over IP. Automatically, also you can configure it manually if you want to change something, but out of the box you can just type secret on both ends and it will create a secure way to communicate. And why I'm saying this and why we added this to all the specific tunnels, because not all, but our equipment start to come out with the CPUs that are equipped with hardware IPsec encryption acceleration. And just one of the latest news, so we had some issues with our CCR hardware encryption accelerator. Problem was in out-of-order packets. So the performance was not there where it should be, so we took our time and we completely rewrote it, the driver for our hardware accelerator. So now it's brand new. And we got a little bit increase in performance. Of course, we solved all the issues with out of order. And with 1400 byte UDP packets, you can now get from 9.2, which was in previous versions, to 13.8 gigabits per second IPsec accelerated traffic, encrypted traffic on 72 core, from 3.4 to 7 in 36 core, and from 1.5 to 2.2 on 9 core. Just by upgrading to version 6.39, that soon will come out as soon as we will return. Because now we can finally add some new stuff for new products, which we didn't because not to reveal stuff. By the way, question about GPS. it was related to the new products. That's why the menu was from the previous presentation also. So that's just a few everyday issues that I have to work with in MikroTik support. I hope I solve at least one mystery of your setups and reduced at least one mail to the support, then it was worthwhile. So thank you. Questions?